So, good afternoon once again. Uh, I said we'll be starting about the classes today. So, to start with the classes, okay. Hope you are able to see the presentation. I just click the textbook material and I'll explain this to you. Can you see the textbook material now?
Yes, ma'am.
Yes, ma'am.
Yeah. So we are talking about classes. Okay. So when last time we said that, so whenever you have a point group, okay, point group. In that point group, you can have, suppose if I'm having C2V or C3V, okay, we can have all the, if this is a group, with this we have written a group multiplication table, okay. Then in that we have done some subgroups, okay. Then similarly the way we have done subgroups. So this is an example. If you see here, these are all the subgroups for the D3H point group. Okay, you can see that there are 12 subgroups in the D3H point group. Similarly, you can have some classes also. Okay, you can have some classes also. So, one second. No? I just want to. One second. This is the little jump. Okay. Now coming to the classes. Okay. So whenever you break this point group into little bit of different groups, you call them as classes. Okay. So before going into these classes, what you have to know is you have to know a phenomenon or operation called similarity transformation. What is that you're supposed to know? You are supposed to know about similarity transformation. I will just talk about this in detail. Okay. So if you take any point group, okay, and think that A, B, X, Y, whatever I'm talking about, any alphabet is a symmetry element in that group. Like if I talk about C3B point group, what are all the symmetry elements in that I will have? I will have identity, I will have C31, I will have C32, then I will have 3 sigma V's, right? So these are the symmetry elements. So if in general, if I take any point group A, B and X, if I take them as the symmetry elements in that particular point group, the thing what you have to understand is whenever I take this product of these three, that is X inverse A and X, will be giving you a answer as B. That is, whenever I do these three operations, whatever I get as the product, okay, that element is also a part of the point group. So whatever you do, whatever product or whatever combinations you do, taking the elements and the resultant product is one of the element of the same group, then you tell that you have done the similarity transform. Okay, what is that you have done? By doing these multiple operations, you are getting a product which is nothing but the element in the same point group. So you are not getting something different, you are getting the same point group. Suppose if I do identity with C31, again identity, I will get the C31 or I will get a C32, whatever it is. So that is a part of C3V point group only, or I may get a sigma, again that is a part of C3V point group. So whatever answer you are getting, that should be a part of the same point group, hence you call this type of product as the similarity transformation. And this A and B are nothing but you call them as conjugate element. That means whenever I do the product of this with X, A with X, I will get B. Okay. So we can simply tell that whenever I do a product of x by a, the resultant is b, where a and b are conjugate elements, and b belongs to again the same point group. Okay. So, and what is this x and x minus? If I take x as a symmetry element, x to the power minus 1 is inverse of this. Okay. When I do inverse of this and multiply with this, I am going to get the b. So, just I list out the rules. Okay, then we will take example for each and every element, symmetry element, then you will understand it better. So let me go through the rules first. So what is that? We call this transformation as similarity transformation, and this a and b are called as conjugate elements. They are called as conjugate elements. Okay, so the first rule tells that every element is a conjugate of itself, that is nothing but the self conjugation. The self conjugation means whenever I do the product, if I take a particular element, okay, and do the uh, product with the inverse x and x minus, okay, I will get the same product. Okay, same thing I'm getting. Then you tell it as self conjugation. If I get a different thing, I will tell A is a conjugate of B. Okay, this is one thing. Then the second rule, so first thing we are telling is self conjugation. That is, every element is a conjugate of itself. Now, second thing I will tell is that if A is conjugate with B, B will be conjugate with the A. So that is a mutual conjugation. First one is self conjugation. Second one is a mutual conjugation. Okay. So how do I represent this? I will tell that if I do the product like inverse of x A and x is B. Okay, so I will tell that the B has come as a similarity transformation of A by X. So this is a product that is obtained by the similarity transformation of A by X. Okay. Then I said mutual conjugation, right? If A is conjugate of B, B should also be a conjugate of the A. So for that case, what I have to do is I have to do again the same thing, that is, but here instead of X, I have to take something else, that is y inverse B and y will give me A. So I will read this as A is coming whenever I do transformation of B by y. This is coming as A by x is giving B, and B by y is giving us A. Okay, so we will tell that the first rule was self conjugation, second one was mutual conjugation. Okay, and third one is associative conjugation. So whenever I tell associative conjugation, we will have three parts, three symmetry elements, A, B, and C. Okay. So if I am telling that A is conjugate with B and C, then I can tell that B and C are also conjugate with each other. So this is simply nothing but your associative conjugation. So again, you have to write x inverse AX is giving B, then y inverse AY is giving C. That means I am telling A is conjugate with B, A is conjugate with C. Okay. Then B will be conjugate with C. That is what we are showing here. Naturally, R, C will be conjugate with B. Okay. So we are showing that again like this. So you can put the same x's here, or you can replace them with P and Q instead. Okay. So what are the three laws? Just now we have done. We said that every element is a conjugate of itself. If two elements are conjugate, you call them as mutual. If three are there, if A is conjugate of B and C, then naturally B will be conjugate with C. So associative conjugation. Okay, these are the three. So we will just take an example of C3V point group, okay, and clarify these above rules. Okay, so what is that we are telling? We are telling that C3V, the symmetry elements in C3V are identity, C31, you can see here, right, C32, sigma V prime, and sigma double prime. Sigma V prime and sigma double prime. Second. So sigma V prime and sigma V double prime. So three uh, What is the example I said? The example you can have is ammonia. So what example I can have? If I draw ammonia, so I have N. Okay. So we have 1, 2, 3. So I have H1, H2, H3. Okay. So we have a C31 and C32 because I have a C3 axis passing through the nitrogen, and 3 sigma V's 1, okay, 2 and 3. So you all agree? So there are 3 sigma V's and C31, C32 and 1 identity element. Okay. So we will see first one by one element and do this type of conjugation. Okay. So what is that we will do? We will take identity. Okay. So in this thing, similarity transformation, we have 6 elements. Okay, 1, 2, 3, 4, 5, 6, and these are with every other element we are going to do. Okay, work out the products using the similarity transformation. Okay. Now sigma v prime and sigma v vertical plane a double prime. These three things are their own inverses. Their own inverses means if I take a plane and take the reflection, okay, and if I do the inverse, okay, that means I am reflecting and going back to the same structure if I do the inverse. Okay, so what is happening? Each these are becoming inverses of themselves. Okay, and C31 and C32 are again inverse of each other. So when we do this, taking the example, you will understand. Okay, so if I do take the identity, so I will put that in the center. Okay, so what is that we have to write? We have to write that I said that x minus 1 a and x should give me the product. So what is first rule is it is its own similarity transformation. So self conjugation. Okay. So E into E into E. So if any molecule I take, if I do identity and again identity operation, what happens at the end of the day? At the end of the operation, what happens? 3 times you are doing identity, or 1 time, or 100 times, or infinity times. What will be the product?
Identity.
Identity. That means you are not doing anything. Okay. Now similarly, if you take C32, then identity, then C31. Okay. So to show this, take your paper. Mm, so I'll just open a Jamboard. Uh, we will see. Open this. Bear with me for 5 minutes. I'll just open the whiteboard. So what is the operation we were talking about? We were talking about C3 2 versus E and C3 1. So we should end up in the identity. Okay. So this is what we did in the last class. Okay. So I'm telling that we are talking about C31, C31. So you please take your paper and do, then write C2 is equal to E. Let me check again whether I'm correct or not. C32 E and C31. Anyhow, both will give the same thing. This is C32 and this is C3. So I have ammonia. I'll just put. Are you all drawing?
Yes,
Yes,
ma'am.
ma'am.
So what is that I should do first? This is the original molecule. Okay. Nitrogen surrounded by three hydrogens, 1, 2, and 3. I've just put that. Okay. So if I do the first thing, that is C32. C32 ante ఏంటిది? What is the meaning? I should rotate this 2 times, right? C31 means I should rotate this 1 time. Got it? So what is that I will get? I will get nitrogen in the center because the axis is along the nitrogen. Okay. And now this one will go 1 time and 2 times. So it will come here. 1 will come here. 2 will go 1 and 2. 2 will go here and 3 will go here. Okay. So now I do the identity means same thing I will get. Okay. So then I will do the C31 transformation for this. See, identity means same thing will come, right? There is no change. Now to the same thing I will do C31. So C31 means I should rotate only once. Okay. So what will I get? I will get nitrogen. 1 will come here, right? We are rotating clockwise. Okay. 2 and then 3. Okay. Now from here to here, what is happening? What is the operation from here to here?
Identity.
Identity.
Identity. Very good. So are we doing the similarity transformation? What is that we got? When you do C32 followed by identity followed by C31, I am resulting in E. So this product is holding good.
Yes, ma'am.
Fine. Agreed.
Yes.
So
Yes,
like
ma'am.
that you have. So like that you have. Whenever you do with identity, whatever you do, you are ending up with the same thing. So C32 E and C31 E. Okay. So same thing. I will just do one more thing for you. Okay, one reflection I'll do. Okay. So this the whole things you can write and you can do the way I've done now. Okay. So one more I'll take an example and do sigma V E followed by sigma V. Again I should get the E. Okay. That is why we are telling reflection is a inverse of its own reflection. Okay. Sigma V's are having their own inverse. Okay. So sigma V E and sigma V. Sigma V E sigma V. We are getting E. Uh, this is the original molecule. Okay, this is original molecule. Okay. Now I do the reflection. Since I'm talking about sigma V, let me put the what do you say, the plane along the first hydrogen. Okay. So when I do the plane like this, these two are reflected, right? So what happens when these two are reflected? I will get the structure like this. That is nitrogen and hydrogen. They don't change. The first hydrogen will not change. Only the second hydrogen comes here and third hydrogen comes here. What is that I have done? I have done the sigma. This is because of the sigma V reflection. Okay. So from the original, I have done sigma V reflection. Okay. Then what is the next thing I should do? I should do again identity. Okay. So identity gives me the same thing. Okay. Then followed by again one more sigma V. So what happens when I do again sigma V? Sigma V is again, I'm telling that the plane is along the first hydrogen. So this is the plane. Okay. So whenever I do, what is that I get back? I get back nitrogen. Hydrogen is in the same place. Okay. Then only 2 and 3 hydrogens are reflected. So I will get 3 here and I will get 2 here. Now look at this and this. Structure 1 to structure the last one. Is it not identity? Yeah.
Yes,
Yes,
ma'am.
ma'am.
So we have to prove that product of sigma v identity and sigma v is ending up into the identity again, right? So we have proved this also. Okay. So in that way, you can prove all these. They will work out the same thing. So what is that we have done? Any similarity transformation you do using the identity, you will get back the identity only. Okay. So you can tell that this identity is a self conjugate. Okay. And it is a class in itself. Okay. And you are getting only one thing, that is the point group belongs to uh, uh, this order of this is 1. Okay, is always 1. Okay, and it is known as trivial class because it is having only 1. Okay, and it is a self conjugate. Okay, and it is giving e all the time. Okay, so you call this as the trivial class. Okay, now same thing we will do with the similarity transformations with the C31 and C32. So if you see here, so no need to buy hard. If you know how to do, you yourself can write. Okay. So I will just talk about C31. Okay. C31, let me take, instead of taking this identity, let me take this one. Okay. So C31, C32, C31, C31. So this is C31 inverse is C32. Remember that. C31 inverse is C32. How is it possible? I'll tell you. You should understand, right, why I'm writing C32 here, C31 here. So I am doing it for C31, so that will be in the center. Okay. Then, so this is A. If this is X, inverse of X will be here, right? So C31. So let me go to the whiteboard again. Okay. So what we are telling? We are telling that C31 mm, C32, C31, C31 is giving again C31. C32. So we are talking about C31s. C31 is giving C31. Why am I telling that C32 is the inverse of C31? Just see. I'll draw the uh, structure here. Nitrogen. Okay. You have all the three. One, three, two, and three. What is the structure of nitrogen? Sorry, ammonia. Pyramidal structure. Okay. So
Yes.
nitrogen is coming out of the board. Fine. So first I will do C31. C31 means I should get clockwise only one part that should be rotating. Okay, so I will have nitrogen. Okay, now you can see that one is coming here. Okay, three is coming here, and two is coming here. Okay, so this is C3. Okay, then I am telling C32 is the inverse of C31. Okay, I will do C3. So what is C32? I said I have to rotate two times, right? I have to rotate two times. So if I rotate, sorry, if I rotate two times, okay, so I will get one will come here, then two will come here, then three will come here. Okay, so C31, C32 is inverse of C31. So this was C31, right? If I do inverse of C31, what happens? Instead of rotating it clockwise, I have to rotate it anti-clockwise. So when I do this anti-clockwise, same thing, one second. Same thing, I'll put one more and we'll see. I'll change color. Okay. To this I am doing C31 inverse minus 1. Okay, here how did I rotate? I rotated clockwise, right? 1 is coming this side. Okay, when I do inverse, what happens? Where will the 1 come? Cheppandi, anti-clockwise rotate, yes sir. 1 will come to the left side. Okay, I will get 1 here. Okay, 2 here and 3 here. Are this not 2 same?
Yes,
C3
ma'am.
minus 1. Yeah. So your C3 minus 1, that is inverse of C31 is nothing but C32. Now do you understand why we are writing like this?
Yes,
Okay.
ma'am.
Now we will check. Yeah. Now we will check C32 followed by C31 followed by C31. I should get C31, right? So C32. So this is the original structure. I'll just continue here. C32. We got this one. Okay. So what I should do next? I should do C31. So from the original molecule, for the original molecule, we have done C32 first. Okay, this is done. Then I do C31. So if I do C31, I will get what happens? 1 annanapudu clockwise, right? I have to rotate clockwise, so 1 will come here. Okay, 3 will come here and 2 will come here. Okay, then I should do one more C31 to this. So please take a paper and pen and you do on your own, the way I am doing. Okay, so if again I rotate, what happens? I get, so 1 comes here, 3 comes here, and 2 comes here. Okay. Now just see this structure. This is simply C31. Okay, and this is again, what is the product you got at the end of the time? All the operations same, right?
Yes, ma'am.
So if I do C32 followed by C31 and then C31, I am getting nothing but C31, right? So we have proved that this product is, the answer is this one. Got it? Okay. So similarly, you can do for all others. Okay, where we will get that when we do, we are getting these things. Okay. So let me do this one. Sigma V C31. Sigma V is giving me C32. Okay, I will do this operation and show you. So at home you can always do. Okay. So on your own, Sigma V C31 and Sigma V. So Sigma V C31. Can you do on? Just see. C32. Sigma V C31. Sigma V is giving me C32. Okay. C32. So I'll just draw first ammonia. So 1, 2, 3. Okay. So first I will do the what I should do. First operation is sigma v. Okay. So sigma v operation I will do. When I do sigma v operation, okay, let me take the plane along the first nitrogen. So let me tell that the plane is like this. Okay. Then these two will be reflected. When these two are reflected, the structure you are going to get is, what is the structure you will get? Nitrogen. Okay. So hydrogen is in its place. So I'll just write 1. Then 2 and 3 are reflected. So 2 and then 3. Okay. And what is the next one we have to do? C31. And where is C31? Along the nitrogen I have to do. Okay. So when I do the rotation along the nitrogen, the thing I am going to get is the product, whatever I get is, whatever I get is. So after I do the rotation, I have along the clockwise, I have one here, okay, one comes here, three comes here, and two comes here. What is that I should do again? I should do a vertical plane. Okay, so I will do this reflection. Okay, so what is that I get? I am doing the sigma v reflection again. So when I do the sigma v reflection, what I am getting, the 2 is as it is, and 3 and 1 are reflected. So 1 here and 3 here. Okay. So for to the same thing, if I do C32, what did I tell? C32 means I should rotate 1 to the second place. So 1 has come from here to here, right? So instead of writing again, let me show that this is nothing but this. Okay, just see the first and the second one, which is nothing but result of C32. So 1 should take 2 times place. So 1 and 2. So 1 has come here. 2 will take 1 and 2. 2 has come here. 3 also will take the second place. 1 and 2 here. Okay. So do you agree now? Sigma V, C3V, C31 and sigma V, the answer you are getting, the product is the similarity transformation formula C32. Right? So this is one of the things. So similarly, if you do for C32 also, you will get like this. So each and every element you are taking. Okay. So E, C3, C32 you are doing E, C32, C31, sigma V prime, sigma V prime and sigma V double prime. Okay. See, when you see this C31, what is the answer I am getting? Either C31 or C32. Can you see? I am not getting the product as sigma, right? Even again in this, when I do the similarity transformation using all the elements for C32, I am getting only either C32 or C31. Okay. For identity, I got only identity. So that was a class in its own. For C3 rotations, I got only two, that is C31 and C32. So I will tell that this is the second class, okay, wherein these two are mutually conjugate, okay, and since these two are conjugate to each other, A and B, the order of the class is 2, okay. So first one was order of the class was 1, but that was a trivial class where only identity has come. Second one we got where we got two symmetry elements C31 and C32 in both the things. Okay. So these are mutually conjugate. Whichever way you do the transformation, you are getting only the either C31 or C32. Okay. So this is the order of this class will be 2. This is the second class. Then third class when you do, that is whenever you do this sigma v's, okay, so whatever way you do, whichever combination you do, you will always end up in either sigma v prime or sigma v double prime, only these three. Okay, only these three you are going to get. So what happens, the order of this class is 3. Okay, so when you work out all this, it shows that the order of this class is 3. Okay, now, so how many classes we have got now in this particular, in this particular uh, C3 point group is, we have got 3 classes. The first one was identity class, second one was the C3 rotation class, third one was the plane. Okay, so these 3 were the classes. So now we have the same examples. Diagrammatically it has been shown. So whatever I have shown, the same thing is being shown here. Okay, doing C3B, or you do taking it as a first, do sigma V, then C31, then again sigma V, you get back the nothing but C32. Okay, this is an example for C31. Okay, now for sigma V transformation also, the combinations. Okay, shall we do this one? You can see it here. Okay, So I will do the first one instead of writing again. I will do the first one. So the first one I'm talking about this thing, that is C32 sigma V, and C31 gives me sigma V prime. So you take the first half. Okay. So this is the first structure. I'm doing C32 sigma V transformation. So this will be in the center. Then C31, end of the any transformation, similarity transformation of the plane, I'll get back the plane only. Okay. So if I do C32 to this, hydrogen should take the second position. Okay. So first hydrogen is taking second position. Okay. So this is C32 done. Now if I do sigma V, that is uh, along the uh, vertical plane. If I do the reflection, H2 and H1 are reflected. So the plane is here. Okay. So these two will be reflected. Okay. Sigma Y is done. Now if I do again sigma 3, 1. Okay. That is only H3 will come here. So only one position, everything will change. Okay. So I have H3, H1 and H2. Okay. So this is nothing but to the same plane. If I do sigma V prime, okay, that is along H2, sorry, sigma V double prime, that is along H3, these two are reflected. So I'm getting the same thing. So what is this combination? The combination was sigma 32 sigma V sigma 31 is giving me sigma V double prime. So do you all agree? The same thing is being shown here. So you can also work out and see, you will get the same answer. Okay. So these are the sigma V transformations that have been given in detail in the textbook. So this is one more example where all three sigmas are there. Okay. This is for sigma V double prime transformations. So all these transformations are given clearly. Okay. So you can do it on your own and see how it is changing. I've already done enough. I think you can do on your own because you know what is what. Okay. So what at the end of the doing all these things, we can tell that C3V is having only three classes, of which one is identity, two are C3, okay, where order is 2, okay, and the other one is sigma base is 3, order is 3, okay. So similarly, you can do for other things, that is C2V and C2H. C2V is what, right? E, 2C2, sigma XZ and sigma YZ. The way we have done for C3V, you can do for this as well as for C2H also. Same thing you can do. Okay. So you can find out how many classes are there in it. So this will come 1, 2 and 3 classes. Here you will get 1, 2, 3 and 4 classes. Okay. So you please work out for this. If you want, we can discuss it in the next class. Okay. So now we will see some important things in the classes. What are the things to be noted when we are talking about the classes? Okay, so this whole chapter was on groups, subgroups, and then classes. Okay, so what you have to remember is, now when you see these point groups, okay, there are only 6 point groups which are of abelian groups. Abelian, I said, abelian is whenever it is commutative. Okay, you call these as the abelian groups, and all other groups will be non-abelian. So these CN, CNH, C2V, D2, D2H, and SN, where N is even. Okay, all these will be abelian point groups. Okay, that means these elements are in a class, they are by itself. Okay, each element is in a class by itself. Okay, the number of symmetry elements or order the group is equal to the number of classes. In non-abelian groups, the number of classes is always less than the order of the group. So whenever I'm talking about abelian, if the order of the point group is 3, I will get 3 classes. Okay, if I am talking about, if the order of the class is 4, I will get 4 as the, that is what we are telling. Whenever you are talking about abelian point group, number of classes will be the order of the group. Okay, classes and group, order of the group will be equal. Whereas if it is non-abelian group, whenever it is not commutative, okay, what you get is it will be less than the order of the group. So no element of the group occurs in more than one class. It's also you have to remember. Some more hints are E is always a class of itself and you call it as a trivial class. Inversion element is also a class by itself. Okay, E and I are uh, classes of their own thing. Okay, then other thing is all these C and M axis are in a class. That is all rotational. C31, C32, or C41, C42, C43. They will all these rotations. They will become one class. So E will become one class. I will become one class. Then rotations will become one class. Okay. Then all the C2s. Okay, you have this secondary axis, right? So all those will come in one class. Okay, then all these improper axis, they also come as a class. So if there are many, you will be placing them in as many classes as possible. Okay, then vertical planes and sigma d, that is the dihedral planes, they are in separate classes. Horizontal plane again will be placed in a different class. Okay, these things you have to remember. Okay, these are the points you have to remember. That is, E will be its own class, I will be its own class, inversion. Okay, then rotations, then vertical planes will come in one class, dihedral planes will come in one class, improper axis of rotation will come in one class. Okay, and if you have a sigma h, that will be again a different class. Again, if you have the secondary axis, that is C2 axis, then also it will be a different class. Okay? So with this, we are done. So just take this last question, 12th question. Work out the products of the following elements in C3V point group. Okay. Please do it on your own. Please write this. Sigma V, C31 sigma V. Your next class, you just show me the white paper where you have worked out this. Okay. Or you can put it in the WhatsApp group. Whoever has attended today, please work out. So I will understand how much you are understanding. Okay. I will have an idea. Uh, this is very simple, right? Just now we have done. So sigma V, C31 and sigma V, what is the product? Sigma V prime, C31, sorry, this is double prime, C31 and sigma V prime, C32 and sigma V, C31 and sigma V double prime. Okay, 1, 2, 3, 4. So four girls, are you there?
Yes, ma'am.
Yes,
Yeah,
ma'am.
Yes, ma'am.
please write down this one. Only four combinations. Please work out and give me the answer in the next class. Okay.
Yes, ma'am.
So in the next class, we will talk about the we have done with the uh, till now we are done with the matrices. Okay, then we are done with the uh, matrices of the elements, symmetry elements. Okay, then we did this group multiplication tables. Okay, then subgroups and then the classes. Okay, next class the I will talk about what do you say, Mm, the matrices in as a point group. Okay, matrices in the point. Okay, so see you all in the next class. Okay, thank you. If you have
Thank
any
you,
doubt,
ma'am.
please please work out. Then you'll get the answer.